Okay, welcome to section 13.1, the start of the last chapter. And this chapter should be a breeze for you because most of it is just review from Algebra 1. So, yay, I have decided this is the quickest format for this way. And since I'm writing everything that you'll be writing, it should be faster on you as well. It might take a little bit longer to watch now, but it should be faster for you to write. So we start by talking about the coordinate plane, which I'm sure you remember. It's made up of two different axes. You have the x-axis and the y-axis. They join together at a point called the origin, and it splits up this plane into four different quadrants. They are the first quadrant up here, the second quadrant, the third quadrant, and the fourth quadrant. And of course, these are our positive numbers, and those are our negatives for our x, and these are our positive for our y, and our negatives for our y. Help you remember a little bit. Okay, so when talking about this section, one of the big things in it is the distance formula. And you will have to memorize the distance formula. So it's d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now the thing about the distance formula is that it's derived partly from our formula for slope. We'll get to that a little bit later. And because of that, it keeps coming up over and over and over and over and over again in math. So it's really not bad for you to get it memorized at all. They'll start you with the distance formula because they'll want you to find the distance between 2 points. So let's say over here, I have the point 2, 3. And then let's say I have the point -2, -1. If I wanted to know the distance between those 2 points, what I'd really be asking is what is the distance of this particular line? Since we're talking about the distance of that particular line, you could think of it as being the hypotenuse of this right triangle. So all we really need to know is what this side is and that side is, and then we can find the hypotenuse to get that. Well, that's what this tells us. It takes the x from there, that 2, and it'll subtract this 2 from it, which means you're really adding them because minus the negative is going to make it a positive, and you're going to get 4. And you can count and see that it's really going to be 4. But when I do this over here, and just the algebra part of it all, I'm going to let this be my x2 and my y2, and this be my x1 and my y1. So I'll say 2 minus my -2 squared plus my 3 minus my -1 squared. When I do this 2 minus 2, I'm really going to be adding those, so I end up with 2 plus 2 squared plus, because of the minus negative, 3 plus 1 squared. So now I've got d is equal to the square root of 4 squared plus 4 squared. Because if you'll look over here, you've got 4, and up here you've got 4. So we really were accurate. So now when I say 4 squared, give me 1 second. Now that we've got 4 squared, that really becomes 16 plus 16, which gives me the square root of 32. We don't know the square root of 32 because it's not a perfect square. But when you're working with distance, we're not looking for decimals. So you can't use your calculator to come up with a decimal. That's not what I want. I want it to be as accurate as possible. We need to be as exact as possible, which means we need to leave it in square root form as simplified as possible. So is there a number that goes into 32? Well, sure there is. We just saw that 16 goes into it. So you could break it down if you want to into 2 times 2 times 2 times 2 times 2, and then start pulling stuff out. But I'm going to break it down into 16 times 2 because I know 16 is a perfect square, which is the same thing as 4 times 4 times 2. And the rule is, because the index is 2, 2 on the inside, make 1 on the outside. So you get 4 square roots of 2 for your distance. Now, back up here, we knew this side was 4. We knew that side was 4. When you look at this, since you know they're both 4, you know it's a right triangle. That means it has to be a 45, 45, 90 right triangle. Which means it has to have the sides 1, 1, square root of 2. So that side would have had to have been 4 square roots of 2. So see, there are some shortcuts that you can use sometimes to keep you from the distance formula. But the distance formula will work all the time. Every time. Whether it's a 45, 45, 90 right triangle or not. As long as we can make a right triangle, which we'll always be able to make because we're on graph paper, it'll work. Now, sometimes, like back before we learned about the distance formula, you would have instead used the Pythagorean theorem. It said a squared plus b squared is equal to c squared, and then solved for c. And you would have ended up with 4 square roots of 2. Either one works. Either one is fine. They're specifically asking you to use the distance formula. And part of that is because you don't always have the privilege of knowing everything. I know that's not any fun, is it? It's okay. So, in your book, they talk about, here, I don't have it copied off, but I do have my book, and I'm sorry I just hit the thing. But anyway, no need for you to see all that over here. Okay, so in your book, for number 6, they want you to give the equation of the line. Now, the reason I'm pointing at it in the book and not worrying about drawing it is because it's faster to do it in the book. So when they're talking about the line BF, that connects B to F, that's a straight up and down line. And I don't know if you remember or not, but when you have a straight up and down line, that means it doesn't have any slope. That means it has to be an x equal equation. And so wherever it crosses the x-axis, that's what x equals. So in this case, x is going to equal 3. For CD, that's a straight across line connecting C to D, which means it has 0 slope, which means it is a y equals number equation. And in this case, y is going to equal 1, 2, 3. Third line up, so y must equal 3. That's the way you need to remember this stuff. Those are the only questions they're going to be asking in this section about lines. They're either going to be straight up and down lines, which are x equal equations, or straight left and right lines, which are y equal equations. So right here where it says y equals 4, they want to know which lines have these equations. So you go up here to where y is 4. That's going to be a line with V and a line with A. So line AV. You could have said line VA. You know how that works. The same kind of thing. X equals means it's up and down. Y equals means it's left and right. Okay. Enough of that. I'm not worried about that one. So, classwork and homework. Oh, look, I'll even write it down for you. X equals a number means it is a vertical line with no slope. And y equals a number means it is a horizontal line with slope equal to 0. And it'll cross through whatever number it's supposed to be equal to. Yep, I'm good. Your classwork and homework. See, less than a page of notes, just saying. On page 538, classwork is going to be numbers 2, 6, 10, 14, and 18. And once again, make sure you do it on graph paper. It'll make your life a ton easier because you'll be able to draw the pictures if you need to. Yeah, you don't have any stress like that now. And these are the practice exercises. I'm pretty sure you know that by now. And then the homework, same practice exercises, numbers 4, 8, 12, 16, and 20. No hard questions. Your hard questions come later. Okay, have a good day. Bye.